All right. All right. So all these talks are really exciting, and I wasn't supposed to be here tonight, but and I know like it was supposed to be Romain Guy, and he was supposed to be talking about really interesting performance stuff, but he couldn't make it. So instead, you have me, and I'm really sorry for that. Um, so my name is Pierre-Yves Ricau. I'm an engineer at Square. Um, And so the one thing I have made in my life, I guess, is this library called LeakCanary. And so I guess I keep talking about it every time I can. So you're going to have to hear about it. But today, instead of what I usually do, which is talking about what the library does and kind of how to use it, I'm just going to go into a live demo. I'm going to start with some of a kind of a high level what's going on, and then very quickly go into a live demo. I never do live demos because I know for a fact that they always fail. Every single time. So we're going to try anyway. We're probably going to fail, but we're going to try. So before we talk about LeakCanary, so kind of to get an estimate, I'm assuming, but I just want to know, who has made an Android app before? Okay, so pretty much everybody, good. Who has had a crash in their Android app before? Right, don't lie, everybody has crashes. If you don't have crashes, then you don't know what's going on in your app. All right, and now let's talk about something else. Those tiny Android devices, they're great, but they don't have that much memory. It's a constrained environment. So I guess who's had an out-of-memory error before? Yeah, no, it should be everybody, unless you probably write better code than I do. That's probably why you don't get those. But we were getting a lot of these out-of-memory crashes at Square. So we made this library, LeakCanary, to kind of help with that. It's an open source library. You can Google it. You'll find it. Memory. How does that work? Let's go back to the Java. I hope everybody has read some Java in their life, but we're going to go to the very basic. There is a class. It's called A. That should be okay. Then there's another class. It's called B. And then there's a third class, it's called C. Okay, so far so good. I also don't have time. So I don't have a timer, which means I have no idea how long this is gonna take. So you're in until like 2 a.m. or something. Okay, we have 3 classes. Let's accelerate a bit. So what we're gonna do is we're gonna create a method a static method that's gonna create a new instance of A, okay? Okay, so when we're doing that, we're actually allocating some memory. Then a new instance, and then we're gonna garbage collect it because the method ends, and that instance we're doing nothing with it, so it goes away, right? So pretty simple. If we do this with B, we create an instance of B. Then after that, it's garbage collected at the end of the call, right? But now let's link these classes together. Let's create fields which are gonna hold the references to the instances of the other classes, right? So we have A that points to B, B that points to C, C that points to A. Great, they all link together, right? So when we create these instances and we link them together, at the end of this method, they're all still garbage collected because Java is amazing and the garbage collector is amazing, and it figures out that, guess what, you actually have nothing that's holding on to those. And so we don't need them, and it just garbage collects the entire thing, which is what we're seeing here. Nice trash. Okay, so cool. Now let's add a static field and just a singleton. And we're gonna assign A to that singleton. Now, when I call this method, nothing happened. The instances are still in memory. Why? Because the singleton is holding on to A, and A cannot be garbage collected. Cool. So what we just did here is some very basic graph theory in the form of Java classes. So if you hate graph theory, you're actually dealing with graphs a lot when you're writing Java code or Kotlin, but I made this presentation a while ago and I was a bit lazy to rewrite it. It's the same though. Okay, so this looks like a graph, but really it's the same thing as we were seeing before. It's a bunch of instances of classes, and these instances have fields that are references to other instances. And the things at the top are things like static fields or local variables on threads, and they are called GC roots, because these things cannot be garbage collected, and therefore anything that they point to cannot be garbage collected, etc., etc. Okay, cool. So the thing in the middle, because nothing points to it, could, just goes away entirely. Great. Now, let's say that we have an instance there that is an activity, and if you know Android, there is a notion of lifecycle. And when an activity is destroyed, it's supposed to be garbage collected. And there's a nice property on the activity class that's mDestroyed, and you can't read it, but it's there. And when mDestroyed is true, it means it's been destroyed, it's supposed to be garbage collected. But here there's like a bunch of classes that are keeping a reference to that activity. So the problem is if this activity has a reference to an entire view hierarchy with a bunch of nice, croissant pictures that are taking a lot of space because there's a lot of butter in croissants, then you're keeping memory around that you shouldn't need. So when we look at what's going on, we can actually kind of trace the path from those GC roots to the leaking activity. And there's not one path, there's a bunch of them actually. There's potentially multiple static fields that points to multiple instances. Actually, in practice, there's always an infinity of paths. And what you want to do is you just want to find one path. And usually what we do, and what we do with LeakCanary is we find the shortest path. Here, that's what's in bold. Cool, and so this is just what LeakCanary does. It finds the shortest path to GC roots on a heap dump. I'll get to that in a minute. But essentially, LeakCanary shows you something like this, which it tells you, okay, so you can actually really map what you're seeing on the graph side. Like every white text is a class name. It's actually an instance, and it sort of corresponds to a square on the side. And every purple thing is a field, a Java field. It's just a reference to another instance, which corresponds to the red arrows. And so if we find, I'm just going to go back for a second. Here, there's a path to GC roots. We have a leak, so we have a bug, but we don't know where the bug is. And the bug is one of these connections is wrong. One of these red arrows is wrong. The activity was destroyed. We should have stopped this arrow, but we don't know which one. And so our job, and we're using LeakCanary to find this reference that should have been removed. Sorry, to allow for the instances to be garbage collected. So if we find it and we fix it, then it's going to be fixed and everything's going to be fine. Okay, great. So that's the end of the theory part, and now everything breaks. We're going to try to make it work anyway, but okay. So Zach, where is Zach? He's over here. Zach Swears made an amazing app called Ketchup. And okay, his app doesn't have any bug at all. It's the perfect, pure app that has all of the great libraries that you want to use. No, it's pretty great though. I think it's very cool. But I added some memory leaks to make it interesting. So what you're going to see tonight is not the app that he made. It's me messing with things. Okay, so this app is essentially, I'm probably not I won't do a good job describing it, but essentially like an aggregator of news from Hacker News and a bunch of other places. And it's called Ketchup. It's open source. It integrates with a lot of interesting, cool stuff. So you should definitely check it out. Also this, you don't need to see this. Let me just, yeah. Let's see what happens when you actually, so once you have integrated LeakCanary into your app, which is like a one-line piece of code that you need to put. Uber. All right, let's press back. And so at this point, the activity is supposed to be destroyed. We press back, we're waiting. And oh my God, there's a memory leak. So LeakCanary is actually triggering. And the way, I won't go into a lot of details, but the way it does that is simply by keeping weak references to instances that it knows should have been garbage collected, like destroyed activities. And then waiting for a bit, waiting for the garbage collection to run and all that. And then doing a heap dump of, so a heap dump is essentially, imagine you have the entire memory of your VM in memory. And a heap dump is copying all that and putting that on the file system. That's it. Just dumping the memory to the file system. And then it parses that to analyze it and find problems in it. Really what it's doing is you saw this graph. In Java, you know the forward reference. You can say this class references this other class, but you have no way at runtime to know who references me. But if you're working on a file, you can actually walk that tree backward and build that. And it looks like we are on a loop of leaks. So I'm just going to kill the app to kind of make sure that we have enough now. We're good. All right. So let's look at the, no, that's not what I meant to do. Enough. Okay, so let's look at the leaks that we saw. So I think that's the one we just did. Cool. All right, so this is what it looks like with LeakCanary. I'm going to try to make it a bit bigger, which is not easy with this thing in the middle. Okay. Big, zoom. The Android emulator is amazing to use. I have no idea how this works. Okay, cool. Okay, so I've tried this. I'm actually going to take that. I've tried this with a lot of colleagues. I made this library. We're pretty happy with it. I was like, it's great. And then people would tell me, yeah, but I don't know how you use it. And I was like, well, it's easy, blah, blah, blah. I hadn't realized that I had spent so much time in it that I knew how to use it, but it wasn't obvious. And so here's what happens. Okay, I'm going to show you this. So this is kind of the entire trace. It's bigger than the screen, so it's hard to see. Does anyone have any idea where the problem is here? Like by just kind of looking at this. Anyone wants to try something? You can raise your hand, you can shoot something. Go for it. The change of hands. I think I didn't hear you. Oh, change handler. Yeah, cool. Could be that. Anything else? Callbacks holding on to the activity. Could also be that. Anything else? So it's a trap. It could actually be both of them. But I'm setting up a trap because the thing that happens every time is that we look at this and we say, this seems familiar, or like here there's an activity. It sounds like it could be that, or it could be, the listener, or you could look at the top and you could say it's that thing. The problem with memory leaks like this is that you can't really guess and you can't really point at the code and really go look. And you have to it's like a little bit like stack traces. When you see a stack trace, you're like, oh, this is my code, so the bug must be here, when that's never the case. So what we're going to do here is apply a little bit of a method. So the method is very simple. I look at these things and I ask one question. I find an object in here, and the question is, should this object be alive at this point in time? That's easy. Should it be garbage collected or should it be alive? So for example, there is a thing called Hyperion.application. So if the top one. The way I read this is Hyperion is a class, and it has a static field called application. That static field is a reference to a class called debug Ketchup application, to an instance of that class, which itself has a field called activity lifecycle callbacks. That's an Android field. You may know that on Android you can set activity lifecycle callbacks that are going to call you back every time an activity is created. That field points to an array list, which itself is backed by an array. So that's what we're seeing here. And the entry number 9 in that array is a callback. And then that callback points to a resumed activity, which is main activity, which has a container, which is a frame layout. And I could go on and go on forever. So for example, we could look at the change handler frame layout. Okay. It's a lot of, I shouldn't have done that because now it doesn't like me anymore. Better. Ha. Cool. So change handler frame layout. All right, so what is it? It's a frame layout. It's really hard to show code on the screen. We're not going to go. So looking at the code is the wrong thing to do, but I'm going to come back to it. The question we want to ask is, should this layout be in memory right now or not? How do we know that? We don't from just looking at this. But LeakCanary comes with something interesting, which is called, I guess, a detail leak trace. I'm going to switch to this guy here. Oh. And it doesn't have all of the logs because that would be too easy. So we're going to trigger it again, I guess. Okay, let me just do it again. And so when it performs, it's going to start doing you're going to see in 5 seconds thing running. Live demo is never working. Told you. All right, so what I'm gonna do is there's always this very nice way to fix things, which is called clear data. That works every time. And then you can just try again. And it's like, hello, okay, cool, first time. Okay, now, 3, 2, 1. Yeah, there you go. Okay, that's what I meant. And then here we have the logs, and hopefully so it wants the permission, which means sure. That's what I was looking for. So let me just copy all of this into a text editor so that we can look at it. So what LeakCanary will do is I'll put something like this. And the top is a text representation of what you just saw before in color, but this is just text. But then for every entry here, we also dump the state of every single instance. And that's where you can find the problem. So if we looked at, say, what was it, change handler frame layout, you're going to, here, you can see there's the instance and there's all of its field. And then there's I'm going to search from here, attach info. So the change handler frame layout was not attached because attach info is null. So that's where you need to start learning more about Android internals. And because I know that, I can go back and look at my leak list. I think we were here with a bit of luck. Yeah, so I can say this change handler frame layout was not attached. Attach info was null. At this point, it was probably attached before, it got disattached, which means that it should be garbage collected. And the way I look at this, I interpret it is it basically means that anything that it references below, anything from this, like the coordinator layout, the view pager, should have been garbage collected as well, right? And so it doesn't matter. What matters is that the problem is above. It is maybe the reference, the container reference that points to handler frame activity. So let's look at main activity. Main activity. Let's go from here, main activity. So if we look at main activity here, we're going to search for destroyed. We are now seeing that the activity is destroyed. And the way we can understand this is that, okay, well, the activity was destroyed. It should not have been in memory. So the problem is above. So maybe it's foreground activity callbacks. And so what is foreground activity callbacks? And that's where it gets tricky because I don't know what that is. Oops. Foreground activity callbacks. It's so it's here. Let's see. It just has a resumed activity. So that's where I start looking into what is foreground activity callbacks. And it's a simple class that is an activity lifecycle callbacks that keeps the resumed activity. And so this is, if you've done a bit of Android before, you're going to immediately notice that this is the source of the problem. What's going on here is that every time an activity, we always keep the latest resumed activity in a field here. So when you're resumed, you're not destroyed, so that's fine. The problem is if there's a new activity that comes in, it's going to be replaced. But if there's no new activity that comes in, such as when we press back, it's not going to be cleared. So like we could fix this by doing I don't know, something like on activity posed, and you could do like if I don't even know how to write Kotlin, but if activity equals resumed activity, then resumed activity equals null, right? Something like that, and that way we would stop having that problem. So this took a bit of time because I was trying to take some time. I don't know how much I got through. Let's look at an even more crazy one. A lot of the memory leaks happen when you rotate the screen. And that is why everybody just make sure the app only works in portrait and cannot rotate, right? That's why you do that. So we're in for a lot of memory leaks now. And so the way, so it's really that same recipe. You look for objects that you know. You try to ask the question, should this object be in memory or not? If you can answer that question, it's great because it's going to help you reduce the space of the problem. If the answer is yes, it should be in memory, then the problem is below. If the answer is no, it shouldn't be in memory, then the problem is above. And you can apply that. And we're going to get some interesting memory leaks soon. I'm just going to kill the app to kind of, what? Are we good? More leaks, please. Yeah, there you go. Okay, we're going to go from. So we have a new one. I'm just checking that this is actually a new one. I think it is. Okay. Selecting text in Android Studio is not the easiest thing in the world. Okay, go away. Give me the text that I want. Okay. That's a lot of stuff. I also apologize for LeakCanary having like this output is not the most readable in the world. I really apologize for that. We need a text designer to help us. I don't know if that's a thing, but like, is there like a job designer job? But yeah, logcat designer. Sorry, I'm just tripping. Okay, so we're back. And we're going to look at, well, so many leaks. This activity leaked 2 megabytes. So this is a much shorter leak trace. And it's kind of interesting. So what are we seeing? At the top, we're seeing app component holder. It sounds like, so a static field to an instance of a Dagger app component. And so we could go down. The key thing, again, is to not look at, just not point a finger. Like you could say, for example, it's the foreground manager impl, because it says foreground, and the other one had like resumed or foreground or whatever. That's got to be that. But we have no idea. So the way I look at this, I look at the top. I'm like, okay, what are we seeing? At the top, we're seeing Dagger app components. If you've done a bit of Dagger, you know that a component is kind of a thing that holds objects, but the app component is the root object. The application class is here all the time. So it's probably normal that this instance is there. It has a foreground manager impl provider. And so we could open that and say, well, the foreground manager impl provider, manager imp, okay, I can't type. Yeah, okay, so the foreground manager impl is a thing that's injected. It's got app scope. Hopefully app scope means it's in the app. So this thing is supposed to stay alive forever. Now, if we go down one level, we're like, oh, wait, it has an activity. That's gotta be it, right? But then if you start digging, you'll realize that it basically only keeps the foreground activity. And as soon as the activity is not in foreground anymore and that you rotate, it's actually cleaned up fine. So that's not the issue. But there's something interesting going on here. And anyone has noticed something kind of weird in this leak trace? Aside from the fact that it's using Dagger, that's crazy. No one should, just kidding. So there is a thing here called main activity, and at the bottom it says main activity. So we have main activity twice. Now, one thing I said at the beginning is that we find the shortest path to the GC roots. What I mean shortest path is if the activity that's in the middle was the linking activity, then we wouldn't go forward. We would just stop there because this would be a longer path than the short path that goes up until main activity here. So there's only one reason that this activity is showing up twice, only one possible reason, which is that it's 2 different activity instances. So like here, the instance of foreground manager impl is pointing to an instance of main activity. And then you have a bunch of references, and then it points to another instance. And we know that the below activity is destroyed because it's been detected as leaking. But what about the top one? So that's where we can go into our text trace again and look at foreground manager impl. Okay. And we can see that, let me see here, it's got an activity field. It's called main activity. Now this main activity, if I look for m destroyed, oops, it says m destroyed false. This activity is not destroyed. So it is actually fine. This activity should be in memory. It's not destroyed. Everything's cool. So what you can deduce from that is that the problem is below. The problem is not above. And we know that the activity at the bottom is destroyed. So it's one of these three. Synchronized lazy impl is a Kotlin thing. And so basically you end up knowing where to look. You're like, well, I guess I need to look at main activity HTTP request helper, which is what we're going to do right now. And I promise this will be done soon. Main activity. Right, and so this main activity has an HTTP request helper. It can be private. Cool, make it private. I don't know Kotlin. And so it's a lazy object, and the way it's done, it says, okay, get the last custom non-configuration instance if you have one. Otherwise, create a new instance of this thing. This thing just is kind of a stupid class that I created for the occasion that just prints when you call connect on it. And then this instance is returned from get last custom non-configure. Oops, not that one. Where is it? It's really hard to with such a big text. Okay, so it's somewhere in there. It's the way. Actually, no, it's this one that I'm looking for. All right, so it's returned here. And so if you've done a bit of Android before, you might realize that what we're doing here is that we are creating this object the first time we need it. But then when the activity is destroyed and recreated, we pass it back so that the system can give it to us again, which works great, except we pass the reference to the activity to that subject, and it's a val, so it's holding on to it. So here, maybe we would just move the activity to be a parameter of the connect method. And then we could keep that object around and everything would be fine. Yes, are you happy now? Yeah. And so this is how we would fix this. So to reiterate here, the way that you can look at these leaks is you kind of scan quickly and you're like, the question is not, do I know this code? The question is, can I make a hypothesis about this piece of code? If it's an activity, I can quickly check if it's destroyed or not. If it's a view, I can quickly check if it's attached or not. If it's fragment, I know if it's destroyed or not. If it's my controller presenter kind of thing, maybe I have some state in there that's going to tell me in what state it should be. From that, I can make deductions and I can look, if it's destroyed, I can look up because the problem is up. If I know it should be alive, then the problem is down. And you can reduce the space and eventually you will find the problem. So that was a very intense presentation. I hope I hope it's going to help you fix memory leaks, and I hope we're going to get less crashes.